Hello, thank you for joining my session at Distributed SQL Summit 2020. Thank you. I'd like to talk to you about a possible path to distributed SQL. I'm going to keep things at 101, kind of, or 100 level, and kind of tell a story on my journey, some of what I've seen. My name is DaShaun Carter. I have been with VMware for 812 days by way of Pivotal. And you can find me on the interwebs at Twitter, GitHub, and GitLab at DaShaun. These are some of the problems that I have had, that my customers have had, and even my side projects. Some of my side projects have gotten a little heavy and more expensive than I cared to admit. So I want you to consider a use case. Just a Java app, RESTful services today, and single node Postgres. This is something that was, probably self-service. Self-service makes it easy to get to this point. It was an MVP. It was something. For me, it was something I wrote 10 years ago. It goes to production and growth happens, right? Things get to scale. I'm going to have you consider one more thing. Just for sake of, consideration, I want you to consider an app that only has value when data is written to the database. So something like a landing page where we're collecting a lead, or it's the actual sale of something. It's only on that write to the database that kicks things off. So perhaps you're facing something similar. This isn't new, right? There are tons of examples and tons of approaches. I mean, we're at, Summit 2020. You've made a decision that you think is going to work. You think it's going to be able to get you out of that MVP, that single node instance, that it's scaled as high vertically as it's going to go, and maybe you're looking for validation for some next step. You've tried it. You've actually probably already scaled your reads. I think that's kind of easier side of this problem, but you're here. You're looking for a way to go forward. And now I'm going to have you consider, for something that you are looking to do, your current roadmap forward, have you considered the cost per transaction? What does it cost? What will that cost? We're measuring ROI. We want to go forward. We want to make it so that each one of those writes to the database, how much does that cost to get there? So there's some additional math here. There's that political, emotional, financial math, and I kind of put it into 3 buckets. I've got my database. I'm an app dev, historically, and I have had to deal with the DBAs. They are the ones that provided that service. So any decision that I was going to make to go from my single node vertically scaled instance to something that was going to solve my GDPR requirements or my actual growth and my ROI requirements, I had to think of what that looked like. A solution that was going from single node Postgres to distributed Postgres seemed like an easier one to make. That seemed like one that I could have some confidence going into. On the app developer side, my second bucket that I was considering, there was emotions, right? Any change to those app developers is going to have some emotions tied with it. So I was considering and considered the move from Spring to Spring. I wanted to be able to accomplish my goals for scale without having to change a bunch of the code. Be able to make that at scale move without having to add a whole bunch. Make it consistent and familiar. But the key, above all, there's this third bucket, right? That leadership bucket, that they care about the business value of making that decision, right? That operator, the director, or even that C-suite, they can point the finger on either side of this problem. Hey, how come we can't manage scale? They can point to the DBAs. How come we can't manage that scale? They can point to the app devs. And probably in a lot of cases, the DBAs and the app devs are kind of pointing at each other. Oh, no, they can't do it. So what I want you to also do is let's make this a decision that we make together. So I'll remind you of my bias. I do work at VMware. I'm a Spring fan. I'm not on the Spring team. I'm a Spring fan. I've seen the value. I've taken it to production, and it makes me happy. Spring provides, in this case, for our example, it provides comprehensive transaction support. It provides a declarative way of executing transactions. If you've ever dealt with EJBs, Spring Data has I would call it a happier path. And maybe you're in the audience for that reason. You're looking for something that might be easier, might allow you to do things faster time to market, better developer experience. But Spring Data has been popular, and it's also very popular just for its consistency. It's consistent abstractions across dialects. You know, a lot of my pipelines literally have like that in-memory H2 database for unit tests, and then another Postgres or MySQL or other database as it goes further down the pipeline. But it's easy. It's not that big of a deal. There's no code required in a lot of those cases. Scaling the reads is easy. You know, scaling the writes, that's the tough part. And the other thing is like, how do you predict that growth? How do you predict what you're going to need? You know, I've been in those cases where, hey, if we decide that we're going to need 10 billion operations per day, and we only end up needing 5 billion operations per day, that's an expensive mistake. Equally expensive, or maybe even more expensive, is saying that, hey, we're going to need 10 billion operations per day, and you actually needed 27 billion operations per day. That can be a really expensive mistake as well. But you don't have to be a Fortune 500 company to get to this type of scale and have these types of decisions. You know, you can adopt these scalable rights as an advantage too, as a startup early. But another consideration is you might have to deal with things beyond your current single node. Maybe at some point you had a single node and somebody said, hey, you need to have this data in another country for something like GDPR. We have to have a solution, and we needed it yesterday. So R2DBC is an option. This is an option that kind of makes that reactive API available for that SQL backend. I'm going to assume that everybody in this audience has done the kind of dance of connection pool sizes for their different clients. Hey, we took this single node from, you know, this much RAM and this much CPU, and we bumped it up. Now, how do we configure all the different clients and change their connection pools so that we can actually utilize that additional bandwidth, that additional capacity, and still not have it fall over? R2DBC is also a back pressure aware, you know, interface all the way down to the database. So if you do have reactive consumers of your SQL database, this is one possible path to help make it reactive all the way down. Again, trying to solve some of these at-scale problems, and this is one potential path. Keeping in mind that cost per transaction. Scaling up databases is expensive. I've lived that Oracle Exadata millions of dollars per year to get those incremental improvements. Again, there's a cost. There's definitely a cost, but look at it at a cost per transaction. If you're using the same use case that I provided earlier of each write to your database is going to generate some value. How much does it cost to get the writes, what you're going to predict to be that next level and get you through your scale problems? How much does it cost per transaction? Is it worth it to say, hey, we're going to, you know, pay for that 10 billion operations per day scale when you only need 5 or only need 1? Is it worth it? But also consider there's resilience involved too. Today in the US, the West Coast is on fire right now, right? Maybe you're nervous about where your data is, and that is setting in for a lot of people right now. Where does my data go? How do I get scale and resiliency? But, and I've said it, and it's my favorite thing to say, I have made my career out of career limiting decisions, and I surround myself with people who have made their careers out of career limiting decisions. So perhaps you're on this journey trying to solve something for scale around your SQL data. I want you to consider, if that is something that you're doing, I want you to consider that cost per transaction while you're making that decision. I think it'll help you, uh, you know, when you're faced with backing up your decisions. But why does it matter? If you're lucky, you will have bigger problems down the road. You're at scale, you're having problems. It'd be great to get through that. But I want you to consider working together. Again, I've kind of proposed 3 buckets: that app dev that is consuming the data service, the DBAs that are providing that service, like what is their perspective? What do they know about the path to the future? But making those decisions together, that 3rd bucket was that leadership, the people that really care and they're, dependent on and compensated on that ROI. That's why it matters. Let's not make shadow IT a thing. So what do we do? So now I've kind of painted the picture of this app that only gets paid. It only generates value when there is a write to the database. And now we are at scale. That single node instance isn't going to work for us going forward. But there's now a DBA that's faced with owning that database. And that DBA maybe has dozens or even hundreds of these single node apps. That's not hard for me to imagine. I have seen that at customers. I have lived that, as an employee. I've seen that. But now on the other side, that app dev, they're faced with sometimes limited options, right? There's not support for the database that they want to use. They've got limited options on what they can do. Maybe there is a Postgres expert, but we have to kind of move forward. And that's where that working together to make the decision comes in. And again, that ops director leadership, they care about ROI at scale. If we can keep that cost per transaction as part of our measurement, then we will be able to make a better decision. So today, wherever you're at with your path to this distributed SQL, what I would first like you to do is start measuring. What does that cost? Measure, see if you can get to that cost per transaction, however it works out, right? Whether it's reads or writes, there's something that you're trying to figure out. There's some next step on your path. But calculate on the cost per transaction model, and you might be surprised. Because at the beginning of any journey, at the beginning of that MVP, that was self-service, I could go push that single node Postgres, 1 cent per transaction, that's nothing. Even if I've just got that credit card up and I'm pushing up to the cloud on a single node instance, 1 cent per transaction, 1 cent per transaction's not a big deal. But when you hit that 10 billion transactions per day, 10 billion writes or 30 billion writes or more, when you hit that scale, that number becomes really important. So what are you trying to get to? That's what I want you to consider. So right now, I'm not going to do live coding. I'm going to show you some example code. This is using Spring Data R2DBC and Postgres, and it happens to be running on Yugabyte. Now, the Spring Data R2DBC is still a module in incubation. So that means you might not be using it in production yet, but its usage will be very familiar. If your app devs, if your teams, if you are familiar with the Spring reactive flows and reactive streams, then using R2DBC is going to be very familiar with you. Again, Spring's consistency across their abstractions is part of what brings people to enjoy it and love that developer experience. Now, Yugabyte, you can find at yugabyte.com. They are a distributed SQL database, and they happen to be Postgres compliant. They have that same usage, that same feel, that same API. So I can take any one of my old side projects that were written against the Postgres database, or old startup code, or old projects, example projects. I can take that was running on Postgres, and now I can run it on Yugabyte. I can have it distributed. So again, I'm not going to do live coding. We're going to look at some code, and just kind of, this is the path. I have more SQL databases in my GitHub repos and my GitLab repos than I do anything else. So using R2DBC and moving things to Yugabyte has just been my path for my journey on learning programming with reactive streams. So I'll go back. We're going to take a look at the code. So I'll scoot back. You can follow along. This is the code that we're looking at. And the main thing is we're just going to skim through it for somebody that's comfortable and has seen Spring data in the last 5-6 years. A lot of this is going to look very familiar. I'm setting up a database, connecting, easy peasy. But controllers, your controllers are going to look the exact same. My imports, I want to make sure I'm not doing anything fancy across the controllers. My domain objects, I don't need to make any changes. This could be a Postgres database. It could be a distributed Postgres on Yugabyte, same. Interfaces are the same for my repositories, DAOs. These things are going to look familiar. So if you're coming from that DBA side and you're trying to get an app dev to move their Postgres from a single node to a Yugabyte, for example, you have this path to say, hey, you don't have to change a lot of your code. Use this driver instead. Or vice versa. If you're on the app dev side and you're saying, hey, I don't have to change any of my code if I could just point this to a Yugabyte instance. It's very familiar. So that's it. I just wanted to point out that this is really very similar. That experience, that step forward is going to be very familiar and comfortable for anybody that's doing, especially reactive with Spring as an example. So going back, how did I get there? Like, why is that enticing to me? I have had problems with scaling. I have had to deal with that cost per transaction issue. And I've also seen customers with those same issues. There's a speed to market. How long does it take you to make that next step? How long is it going to take you, once you've made a decision, how long will it take you to get that to market? If you are using something that's familiar to both sides or multiple stakeholders in the equation, I'm suggesting it's going to be easier. It's going to be easier to adopt. Yugabyte is just one example of doing it. And for the app developers, Yugabyte Cloud is free, still in beta. But the key is work across, right? Try to avoid going down that rabbit hole of, oh, I'm going to make this decision. I'm going to pick something that's going to work and I'll prove it. Think outside the box. Think about reaching out to your stakeholders before you make that decision. Do an example. Take an example of some of the solutions that you're considering and put that single cost per transaction metric. Try to make that a part of your decision so that your next decision on your distributed SQL journey, make it a data-driven one and include that cost per transaction. Thank you. And now I hope you'll join us for the Q&A session.